Okay, Aoibheann, so you are going to be the teacher next Tuesday, okay? And this is how I would introduce trigonometry. And the first thing I'd introduce is Pythagoras' theorem. Just to say, so first of all, trigonometry is all about triangles, okay? And triangles are kind of magical enough shapes. And Pythagoras' theorem says that in any right-angled triangle in the world, and a right-angled triangle is one that has a 90-degree angle, but in any one of those triangles in the world, that if you give him two of the sides, so if you gave him this side and this side, he would be able to find the length of this side. Okay, so sorry, I said if you give him this side, I mean if you give him the length of this side and this side, then he'll be able to find the length of this side. And likewise, if you gave him the length of another two sides, so if you gave him the length of this side and this side, he'd be able to get the length of this side without measuring. Okay, so it's kind of magic. You give him a triangle, you give him the length of two sides, without measuring the third, he'll be able to get the length of it. So that's where we're getting to at the end of this, right? And there's a formula that Pythagoras would have came up with to allow him to do that. But before that, I would always start with the history of the maths. So I would go back 2,000 years ago. Okay, just to say, Pythagoras is credited with this, okay, with discovering this. However, he didn't discover it all on his own. So if you went back over 2,000 years ago, say 4,000 years ago maybe, to the ancient Egyptians, they were very interested in triangles as well. And I would ask the students, why do you think the Egyptians would be interested in triangles? And they would say, well, pyramids. And that is exactly right. I would also say, and I told you already, the Egyptians used to measure in cubits, which was the length of the pharaoh's elbow to his hand, top of his finger. And the Egyptians found this out, that if they had a right-angled triangle, and if this side here was 3 cubits, so the length of 3 of his elbows to the tip of his finger, so 3 up that way, and if this side here was 4, then the diagonal was always going to be 5. And they could make sure, by that logic, the 3, and the 4, and the 5, they could make sure that their triangles were, in fact, right-angled. Because if they had a triangle that measured 3 high and 4 wide, and the diagonal was 5, they could say, yes, this is definitely a right angle, which would help the pyramids to stand up straight. Okay? So, Pythagoras moved it on from there, though, because the Egyptians only knew this triangle, the 3, the 4, and the 5, or, another way of doing it, 4, 3, 5, but the diagonal would have always had to be 5. But Pythagoras said, well, actually, if you give me any triangle, any right angle triangle, I don't care about the lengths. It doesn't have to be 3 and 4. You give me a right angle triangle and give me any of the two lengths, I'll be able to find the length of the third side. But just to tell you about Pythagoras, so Pythagoras was a leader of a kind of a cult, and they were a crazy enough cult. They believed they could speak to the animals, and they believed it was evil to eat black beans. But they were geniuses, and they were brilliant at maths, and they looked at the maths of music as well. Okay, so they discovered a lot of good things. They lived in ancient Greece. Pythagoras had a student who actually found a problem, or so he thought, with his theorem, and Pythagoras murdered him. Now I will be teaching you about that in the next class. Okay, but for this class, how did Pythagoras do it? How did he come up with a method for finding out the length of the third side? Well, let's just take the one that the Egyptians knew. And this is what I would do for you. I explain this to the students, all I've explained to you. And I would take the triangle that the Egyptians knew about. Remember, it has to be right angle. And the one the Egyptians knew about was the one with length 3 and 4 on the sides. And they wanted to find the diagonal. And here's Pythagoras' theorem. H squared equals a squared plus o squared. Or you might see it in another place, a squared equals b squared plus c squared. Okay, but I like saying h squared equals a squared plus o squared. Now, what is A, what is O, and what is H? Well, the most important thing for you to know is H is always the diagonal. Okay, so it's the longest side. Okay, so I actually forget I said diagonal. Right? It's the longest side. H is the longest side. It's also the one opposite the right angle. Always, always, always. And H, we write H, but it actually stands for hypotenuse, if I spelled it right. Okay? In Pythagoras' theorem, the O and the A are the other two sides, and it doesn't matter which is which, so I can call this O and this A, or vice versa. I can call this A and this O, whichever I want. Okay? When we go further on in trigonometry with a few different things, not Pythagoras' theorem, it will be important which side is O and which side is A, mostly in leaving cert, okay? But so far, all you have to know is the H is the side opposite the right angle. It's always the longest side. And all we do is we fill in what we know into this formula. So, do I know the length of H? No. So, I'll just leave it as H squared. Do I know the length of A? Yes, I do. It's 4 squared. And do I know the length of O? Yes, I do. Here it is. It's 3. So plus 3 squared. Now, this is just an equation, so work it out. H squared equals 4 squared is 16, plus 3 squared is 9. H squared equals 16 plus 9 is 25. I have an equation now. I need to square root both sides because I don't want H squared, I want H. H equals 5. Okay? And that's what the Egyptians knew, isn't it? H equals 5. So we're just after proving it via Pythagoras' theorem. Here's another one then. Let's go 7 and 2 and x. Okay? And there's our right hand. First step, okay, and we'll take the class through the steps, right? So, step 1, label, step 1, write formula. So I'll do that. H squared equals A squared plus O squared. Okay, so there's step 1. Step 2, label sides O, A, and H. Right. I always label H first. The H is always the longest side and the side opposite the right hand. The other two, it doesn't matter. O and A, whichever I want. Step 3, put O, A, and H into formula. Okay, so this time I know what the H is. 7 squared. The A is x. I don't know what it is. Squared. The O is 2 squared. Work it out. 7 squared. Okay, and this is step 4. Work it out. So 7 squared, 49 equals x squared plus 2 squared is 4. Now I have an equation. My unknown is here, so I have to do a little bit of algebra. I'll take away 4 from both sides. Take away 4 from 49, I'm left with 45 equals x squared. Square root both sides. And the square root of 45 equals 6.7. Okay, so x is 6.7, so the length of this is 6.7, and probably centimeters. Okay, so at the end, if I know it's centimeters, I will call it centimeters. Okay, that's it, Aoibheann. That's all I want you to teach the class. And for homework then, you may look at your book and give them a few nice, easy questions to do. Okay, maybe just 3 of them to get them started. Okay, just check the book actually. 1 second, I'll check it and see what page they're on. Okay, just bear with me. Okay. 7. Personally, I would probably give them question 4, page 4, 9, 8, okay? I wouldn't really bother with questions 1, 2, and 3. But you can make your own up. You can say there's a triangle, there's a right angle, this is 7, this is 8. Find that. It's as easy as that. Okay? So that's it. Best of luck. You'll be fine. Okay, and well done for taking up the challenge. Okay, thanks.